Hi there and welcome back to another Papetti Math YouTube video tutorial where today I am going to be teaching you, yes you, Algebra 1. And in this video we're going to finish up our look at the axis of symmetry regarding parabolas. And it says, given a quadratic equation in the form y equals ax squared plus bx plus c, you could find the axis of symmetry using the formula x is equal to negative b divided by 2 times a. And there you have your axis of symmetry formula. It says x equals negative b divided by 2 times a. So we could use this to find it algebraically. So using this formula, we're going to find the axis of symmetry of the following quadratic equations in exercise number 4. Then we're going to substitute the x value into the function to find the vertex. And then we could check our answers using a graphing calculator as well. So in part A, the first thing we want to do is say, well, we're finding our axis of symmetry. Let's use our axis of symmetry formula, which we'll get used to memorizing because we're going to be using it so much. So x equals negative b divided by 2a. Now, what would be helpful is knowing our a and our b values. So the a value is the coefficient of x squared. And if you're looking and you don't see a coefficient, that's because your coefficient is 1. And your b value is going to be negative 20 because that's the coefficient of x. So we have an a value of 1 and a b value of negative 20. If we were to substitute this into the axis of symmetry formula, we're going to have negative 20 divided by 2 times 1. And that's going to give us a positive 20 divided by 2, which is 10. So our axis of symmetry here is going to be x equals 10. Now, in order to find our vertex, it says to substitute the x value from the axis of symmetry into our function. So we're going to find g of 10 now, and that's going to be x squared, so 10 squared minus 20 times 10 plus 2. And g of 10 is then going to be 100 minus 200 plus 2. And if you go ahead and do that, you get negative 100 plus 2 is negative 98. So your vertex is going to occur at 10, negative 98. And if you go ahead and put this in y equals, or this in your graphing calculator, you will see that the vertex is in fact 10, negative 98. Let's go on to the next one. We have h of x is equal to negative x squared plus 8x plus 10. So our axis of symmetry, again, we're going to need to know what our a value is and what our b value is. Well, a is the coefficient of x squared, so that's going to be negative 1. And b is the coefficient of x, so that's going to be 8. Now that we know that, we need our axis of symmetry formula, which is negative b divided by 2 times a. X equals negative b over 2a. So let's substitute into that formula. So we're going to have negative b, so negative 8, divided by 2 times negative 1. That's going to be negative 8 divided by negative 2, and that's going to give us a x value of positive 4. So our axis of symmetry is x equals 4. Now we want to use that to our advantage to find the vertex. So we're going to substitute 4 in for this function. So we'll have h of 4 is equal to negative 4 squared plus 8 times 4 plus 10. And now we're going to have h of 4 is equal to, well, our order of operations says to square the 4 first, so that's going to be 16, negative 16, then plus 32, plus 10. And when we combine our like terms, or we just add together all of our constants here, we'll have negative 16 plus 32 is 16, plus 10 is 26. So h of 4 is equal to 26, and that means that your vertex occurs at 4, 26. And again, if you check that in your graphing calculators, then you will see that the vertex does in fact occur at 426. So we don't actually need a graphing calculator to solve something algebraically. As long as we have an equation, we could figure out the axis of symmetry and the vertex without using a graphing calculator at all. So let's take this with us going into part C. And in part C now, we have k of x is equal to negative x squared minus 13x minus 28. And again, we want to know our a value and our b value to get us started. And the a value, again, is going to be negative 1. And our b value is going to be negative 13. So axis of symmetry we find by using x equals negative b over 2a. And let's go ahead and substitute into that formula. Negative b, which is negative 13, divided by 2 times negative 1. Well, a negative 13 is going to be positive 13 divided by negative 2. And that's going to give us a negative 6.5 as our axis of symmetry, which we could rewrite a little bit neater as just the axis of symmetry of x equals negative 6.5. All right. Now, to find our vertex, we want to substitute negative 6.5, in for x every time we see an x. So we're going to do k of x, k of negative 6.5, is equal to negative 6.5 squared minus 13 times negative 6.5 minus 28. Let's simplify this a piece at a time. So we're going to start off by going k of negative 6.5 is going to be, well, negative 6.5 squared is positive 42.25. And we add in this negative in front, and we'll have negative 42.25. And then we want to know what 13 times negative 6.5 is. Oh, well, we have a negative 13 times a negative. That's going to be positive 84.5. And that's going to be minus 28. So now we could go ahead and we could combine all of our like terms here. And we're going to have negative 42.25. And we're going to have plus 84.5, which will give us positive 42.25. And then we're going to subtract 28, and we're going to have positive 14.25 there. So our vertex is going to occur at negative 6.5, comma 14.25, which now shows us that we can not only find axis of symmetry or axes of symmetry for whole numbers and integers, but also for decimal numbers. We can find the exact value of a vertex down to the thousandth of a decimal place. Even further, no matter what the equation is, our axis of symmetry formula will work for it. And we will also be able to find the vertex using that axis of symmetry formula. So if this video was helpful in finding the axes of symmetry for these 3 parts of this exercise, please give this video a thumbs up. And you're now ready for lesson 4. Thank you for watching.